So we have about 8 or 10 minutes. If there's any questions, why don't we tee those up now? If not, we'll have some other questions I'll ask. But any questions right now?
This is the top. How much resistance did you get in asking the older guys to give up their intellectual, their secrets?
We had to make death threats to get it out of them. No, Duke is made of 4 older companies that are made of about 8 other companies. We knew we started strategically doing, we're in 4 big regions. We started strategically with a region where we knew we were going to get buy-in. And then we went to another region where not as much buy-in, but we could get it. By the time we got that part done, and we were sharing that with the region coming up, and they were seeing the guy get done with a 3 or 4 week project in a week, and his is due next month, and he ain't getting the HRM solution for 4 months, getting pissed. Okay? So we did a lot of strategic planning. The other thing is we've been working on this project for 8 years. It took 4 years to convince people we needed to spend money on it. Then it took 2 years to find a solution that would work with what we knew were known problems. And then it's 2 years in implementing it. So when I said 2 years, that's just the implementing. We started a lot of the stuff that we're feeding it years before we actually even picked out a software solution. The prime example I'll give you is our failure data. These are, like I said, $1 million assets. I couldn't go any place and have a list of what $1 million assets failed and why. What a guy called a failure in Cincinnati was not what a guy called a failure in Kentucky, was not what a guy called a failure in the south side of the mountains, nor on the coast of the Carolinas, and then the 3 guys in Florida that did it. Well, okay. So we had to set up things like a failure database. We call it DAD, Decommissioned Asset Database. All right, and the reason why we had to do that is I've been with a company 12 years and I've seen 3 changes in asset management systems. And my background is in asset management software for an asset management software company. One of the biggest things we see is I'm going to a new asset management software because I want to do this. Okay, great. You know, it's going to take a lot of money to convert all that old history for equipment that we got rid of. So we're only going to do it for the active live equipment. Lose all of your failure analytics. How do I do predictive modeling if I don't know what makes things fail or have failure data? So we realized that early on. So the culture shift is taking 8 or 9 years. It's not the answer is it's been really hard. And when we were developing the analytics to put into the system, we plied them with booze and good food. We had this big, long business process meeting. And then I get all the subject matter experts and say, come on. Got them in a room, catered really good food, and had what I knew were their favorite whiskeys and beers in there. And 3 people taking notes, and we sucked them dry for every analytic calculation. How would you do it for 4 nights? And then we got them in there, and they go, oh, man, you know. But it was a lot of work. And the culture change on it is just now getting accepted, knowing it's been coming for 8 years. But you got to remember, a power company, we got people that, like I said, 40 years, retirements are kind of common. Nobody leaves, you know.
Steve,
Unfortunately, we can't get young people in anymore because they won't hire apprentices. You got to have 10 years of experience to get a job. But what we had to do is, and some of the stuff that was hidden, they sent us their stuff and we spit it back at them. They go, oh, that's wrong. And I go, no, that's on the spreadsheet you gave me. They goes, well, that spreadsheet didn't have the details you need. I go, well, where are they? They go, well, hang on. You know, all of a sudden they were having to use the data they gave us. And I got to get you more data. So, but from the time we started, in fact, we didn't even have monthly transformer health calls to review these things. We started that 6 years ago. It took 5 years for them to start participating.
Steve, did you have a comment to it?
Culture change.
Yeah, I think Tom pointed out is that you have to demonstrate that the new world is better. So, any other questions?
Yeah.
Just to add a little on this question, from Braskem, this project was similar to choose the region that they would have the buy-in to start, and they had the support of the director of the region, and the kickoff of the project in the keynote. He talked to every one of the operators that this is important, the company need to change, and this will make we go forward. So this was really important. And the second thing, this guy that has this spreadsheet, if you come to him with a black box, he won't accept this. So if you come to him, let me learn from you what we are doing, what are important, what the key indicators that we are looking. Let's work together. Let's talk the same language and incorporate this in something that will make your life easier, and you know what is inside. So then this guy will accept this and will use the solution.
I think we have one more question here.
Yeah. Excuse me. Just had a quick question for Gustavo or José. You kind of got cut off there at the end, but could you speak just a little bit to the results that you guys actually got with the project? Because we saw early in the presentation that there was about $1 million in investment, about $5 million in return. So can you just speak to some of the other results?
Okay. If you can put just the last slide, I can show an example to demonstrate one real case. And it was the two last slides of the presentation.
Alice, can you go to the end, please?
So
Thank you.
I'll start talking. The first example that we have is from a pyrolysis furnace, and it's an example that where we use an indicator with engineering calculation. So there is no machine learned model. It's a phenomenological equation. And the pyrolysis furnace, they have to clean, just forward a little bit. One more. But this one. So we created a thermal distribution indicator, and inside the furnace, they have to clean the burners from time to time. So in this case, when you have a clogged burner or something that is misplaced, it leads to what we call an unbalanced furnace, and it reduces the campaign time, and then we have to stop early, and the company loses money. So with this thermal distribution indicator, this was one real case that we saw indicator of a specific part of the furnace going up, and it stays up until 4 to 45 days. And during this period, the furnace was shut down because of commercial reason. The furnace then was turned up again, and they continued producing. And after 44 days, they realized that it was unbalanced and fixed the furnace. And then when we look at the data, this indicator was already showing this right before, and they had time when the furnace was down to fix it. So it's a great example, that indicator that can show where the problem is and show to the operator. They have a schedule to do the cleaning and the checks on these burners, but in this schedule, sometimes they are looking to this routine, but sometimes the problem is not what they are looking right now. They will be looking just ahead when they found the problem. So the key message here is to give insights and to give information where the problem is, and with this kind of indicator, they can plan this kind of maintenance where the problem is, where the furnace is more unbalanced, and save money and extend the campaign time of the furnaces. And for furnaces, the campaign time is very important, with a couple or 3-4 days of extra campaign time. In a year, we have millions of dollars in saving. They are really big equipment. So this one, great example. And the next slide, please. It's a different example of a mechanical failure that we use that statistical twin to detect a failure condition. So this diagram on the bottom shows a little bit better. The discharge temperature was the variable that we're monitoring. You used the motor power, the suction density, the suction pressure, and the suction temperature to predict the same discharge temperature, compare with the real one, with the twin one, and with the residue, and the distance between each one to decide if it is in a pre-failure condition or not. And we have cases with more than a month before a failure, the indicators goes up and this residue increases, and they can plan a schedule. They can schedule a maintenance and do a predictive maintenance and not wait the plant to stop.
Thank you, José. Thank you. And thank you all. I think we're time for your dinner time or whatever you're doing. Thank you for the panel for a wonderful presentation.
Thank you very much.